Hey there, Math Hoppers. In this video lesson, we are going to learn how to add and subtract matrices. But before we do that, we should figure out what a matrix is. So, guys, super easy. A matrix is simply a rectangular arrangement of either numbers or variables or expressions, and it's organized specifically into rows and columns within a set of brackets. So what I mean is this exactly. And this matrix is called a 2x3 matrix simply because it has 2 rows and 3 columns. So its dimensions are how it gets its name, or what we call it. We call it a 2x3 matrix because it has 2 rows. Row 1 has the entries 1, 2, and 3. Row 2 has the entries 4, 5, and 6. And then 3 vertical columns. Column 1 has 1 and 4. Column 2 has 2 and 5. Column 3 has 3 and 6. So notice I keep calling these things entries, and that's what they are. You may see them called elements. The individual, easy for me to say, values within a matrix are called entries or elements. You'll see both terms used, and they are often denoted with this A subscript ij, and this is very specifically an element locator, where I is the row number and j is the column number. So if you were to be asked to find element A subscript 1, 2, it would say find the element or the entry in row 1, column 2. Row 1, column 2 would be 2. So A subscript 3, 3 represents the entry 6 because it is the 3rd row, 3rd column, and it is that entry right there. Okay, so remember, matrices are named R by C, row by column, right? And why is it R by C? R by C is because those are the dimensions. The definition of a matrix is simply row by column. We couldn't call, if I go back to this last page, we couldn't call this a 3x2 matrix because a 3x2 matrix would need 3 rows and 2 columns. So let's see a 3x2 matrix. This right here is a 3x2 matrix. And it is a 3x2 matrix because exactly what I said, it has 3 rows and 2 vertical columns. Notice we now have a label, A equals. Matrices are often labeled with capital A or capital B. If you had 3, they'd go right down the line, capital C. So capital letter is what we used to label a matrix. Okay, so what does it take for a matrix to be equivalent to another matrix? This is very easy. Each entry, all corresponding entries, have to be identical for the matrices to be equal. So these 2 matrices are equal. -2 corresponds to -2, 3 corresponds to 3, 1/2 to 1/2, -1 to -1. These are not equal. They all have the same values. They are not in corresponding locations. -4 corresponds to 3/4. 3/4 here corresponds to -4, and vice versa. Here, down here you have 3 corresponding to -2. Really all you need is for one of these to not match, and they would not be equivalent. Okay, so those are the basics. How do we manipulate the matrices using addition and subtraction? So to add or subtract matrices, they can only be added or subtracted if they have the same dimensions. And once we see how to add them, this is going to make total sense. Because when you add or subtract matrices, you're adding and subtracting, or adding or subtracting the corresponding entries. So the exact same elements in the exact same position get added. So if I were to add these 2, I would have to add this top left to this top left. So row 1, column 1 would have to be added to row 1, column 1. So you see why they have to have the exact same dimensions. I need corresponding entries to add or subtract. So if this had an extra column here, there'd be nothing to correspond over here with, and I could not add or subtract them. So let's see what I mean. 2 would be added to 3. -3 would be added to -1. And then these would be placed in those corresponding positions, as we'll see. 1 would be added to -5, and -4 would be added to -3. And when we write the sum of the 2 matrices, we place them in corresponding. Because I added row 1, column 1 to row 1, column 1, the sum goes in, guess what? Row 1, column 1. Pretty intuitive. Row 1, column 2 gets added to row 1, column 2. The sum is placed, guess where? Row 1, column 2 of the sum matrix. If we add all these together, we get 5, -2, -3, -7, as long as I didn't make a calculation error anywhere in there, and it looks like I did not. Okay, so let's practice. We usually don't make too many mistakes adding. Mistakes usually come in when we subtract, and that's pretty much how it goes for anything, especially when integers join the game. So if I were going to subtract this matrix from this matrix, I would just go position by position. -5 minus 2. Be careful to denote the subtraction each time. So I would take -5 minus 2. Then I would take, and I would put that in the top left, 6 minus -1, -3 minus 4, and -3 minus -2. This is the one we want to be careful with. So when you're first learning these, go ahead and put the actual expression into the matrix before you simplify it. So I can see that this was -5 minus 2. I can see this was 6 minus -1. Remember, I should see a subtraction sign in between each set of numbers, and then if -1, if this was actually negative, I should see another negative. So 6 minus -1, remember that's 6 plus 1. -3 minus -2, -3 plus 2. Okay, so let's see what the difference of these two matrices is. It is -7, -7, 7, and -1. Perhaps 7s are lucky today, or I just had 7 on the brain when I wrote this. All right, we have added them, we have subtracted them. You will often be times given a scenario and asked to write a matrix to match the scenario. So let's do one. A DVD rental box service labels its DVDs into either new release or classic, and new releases are defined as movies that have been released within the past 4 weeks. Okay? So these movies are also placed into one of the following categories. So you can be new release or classic, comedy, drama, suspense, or children's. Write a matrix to represent a rental box that has a whole bunch of information here. 41 new releases, 115 classic. 12 new releases are comedy, 15 are drama, 6 are suspense, 8 are children's. So of the new releases, you have 12 new release comedy, 15 new release drama, 6 new release suspense, and 8 new release children's. You have 32 classic comedy movies, you have 45 classic drama movies, 15 classic suspense movies, and 23 classic children's movies. So this would look like that. You have your new release, you have classic, and then you have all the different categories here. So when you see an actual example of some data put into a matrix that represents a scenario, you could see why to be an equivalent matrix, you have to have identical entries. Let's say there were 2 DVD box services. They had one box in one town and another box in another town, and they were comparing inventories. If the one matrix had a 12 in the top left, but a 15 in the top left of the other, they would not be identical. That would represent 12 new release comedies, and the other box would have 15 new release comedies. So each individual entry in a matrix represents something super specific. All right, let's use another example that comes up usually in Algebra 2. Before you get into college math with matrices and do a whole lot more with them, you usually find a profit matrix. So a profit matrix would take 2 matrices to determine that profit. What I mean is, let's say Jen owns a pet supply store. The matrices below are going to show the revenue and the expenses for the first quarter. So here's her revenue matrix, here's her expense matrix for store 1 and for store 2. And remember, quarter 1, we're talking the first 3 months of the year, right? So they want us to use the matrices to write a profit matrix for both stores. One matrix representing the profit for both stores. And this is really a glorified, hey, subtract these 2 matrices. That's all you have to know here, because when you take revenue is the money you've brought in, expenses, the expenditures or the costs to run your business, and you want to find profit, you do so by subtracting the expenses from the revenue. So you would take the expense matrix and you would subtract it from the revenue matrix. And it would look exactly as you imagine it would. We would take store 1 January's revenue minus store 1 January's expense. We would get $12,450 minus $7,225. And we would come up with our profit matrix by subtracting each of the corresponding entries. Okay, so that's the basics on matrices. If you're doing something else with matrices, there's something in your classwork or a test you're studying for, and this video didn't cover it, or you just don't understand it, you should be subscribed to our YouTube channel. It literally exists for you. It is there for you to submit problems that you're having trouble solving, and we will put together a custom video solution for you. And then you won't have any trouble solving it. All right, Math Hoppers, until next time, take it easy.